All right, good morning, fifth graders. Today we're going to talk about multipliers to simplify and unsimplify fractions. We've been working on multipliers a lot with our fractions. So for example, if I wanted to find an equivalent fraction to 3/5, I know that I could multiply it by 2. And I know that some of you like to write just the simple 2 here. I really prefer to put it on the numerator and the denominator just to keep things clear here. So I could multiply it 3/5 by 2, and I'd come up with 6/10. Now I know this because yesterday we talked about our fraction bar. If I did it in fifths, and I drew one right below, right? We compare them. I have 3/5, and then in order to get it into tenths, I have to split everything into 2. So I split, split, split all the way around. And then 1, 2, 3, 4, 5, 6. These two are still equivalent. The pieces are smaller. It takes 2, hence the 2 here, 2/10 to make 1/5, but it's still the same. So I could continue this multiplier pattern on and on and on. I could multiply it by 3. I could multiply by 4. As long as you keep the numerator and the denominator multiplied by the same number, it will continue to be equivalent. So now I'm going to ask you a challenge question here. What if I have 3/5 and I want to turn it into 18/30? Take a quick second to think, what does my multiplier need to be? Well, if you're looking at this, you're like, I know 3 times 6 is 18, and then 5 times 6 is 30. So we've gotten really good at the multiplier, but now my question is, what if I want to go smaller? What if I'm starting with a large fraction and I want to go smaller? So this is kind of a funky fraction. What if I'm starting with 27/45 and I'm looking at it and I say, I want to simplify it. And simplify means to make it smaller, to make it into its smallest form. So obviously, or simplest form, 27/45 is definitely not the smallest form I could get. So the first thing I would do is think of what goes into both 27 and 45. I need to divide it by something, but remember, if I'm dividing or multiplying, I have to divide by the same thing. So it has to be able to go into 27 and able to go into 45. So if I was taking a second, I'm thinking, hopefully you're thinking with me. 9. I know that 9 times 3 is 27 and 9 times 5 is 45. If I divide the numerator, I also have to divide the denominator. The same thing here, guys. So I'm like 27 divided by 9 is 3. 45 divided by 9 is 5. Can I go any smaller than 3/5? Well, 3 is a prime number, 5 is a prime number. We're not going to get any smaller. So that's one way. We've gotten really good at this, unsimplifying them, making them much bigger. But today we're going to continue to work on making them a little bit smaller. So I'm going to give you another one here where we have to simplify. So let's go with I'm going to leave this one here for you really quick. And I want you to think about, first thing you need to think about, okay, is what can go into 35 and 42? So take a quick second to think. All right, hopefully you came up with 7. Because I know that 7 times 5 is 35 and 6 times 7 is 42. 5/6. Can I make that any smaller? Can I divide 5 any smaller? 5 is prime, so I can't go any smaller. So you're always trying to get down to the simplest form. And again, if you wanted to make it bigger, you can do the opposite way around. If I wanted to multiply it by 7, I would get the same thing. You guys are still fact families. Just keep in mind your numerator and denominator have to be multiplied or divided by the same number. Otherwise, the fractions will not be equivalent. So what if I took 42 and I'm like, oh, I'm going to divide this one by 6. I'm going to divide that one by 7 because I know 7 goes into 35 and 6 goes into 42. All of a sudden, I'm left with 5 sevenths. Well, 5 sevenths isn't equivalent to 35 40-seconds. So double check, please, please, please make sure whatever you do to the top, you got to do to the bottom. That's our rule for the day. And it's going to stay that way with both division and multiplication. So now we're going to talk about these chains of equivalent fractions. And this is pretty easy to do. I'm going to start with 3/8 this time, not 3/5. We're going to mix it up a little bit, 3/8. So I know that I can find equivalent fractions by multiplying as long as it's the same as the numerator and the denominator. So I could do, like I said before, times 2 would get me 6/16. I could go 3/8 times 3, give me 9/24. I could continue this on as long as I wanted. And as far as you needed it to go for whatever problem you're trying to solve. And you'll continue this on the same way. I'll go a little further for you here. We'll go times 5. And so now we're at 15/40. So we could line these up as a chain of equivalent fraction, okay? And we could have, we started with 3/8, then we had 6/16, then we had 9/24, then we had 12/32, then we had 15/40. I'm going to erase the underneath work so it's not quite so messy. But you'll notice a lot of these fractions have really little pieces. And if I was to draw them out, they'd be so tiny, like 40ths, but they're always going to be the same as 3/8. So I like to draw my eighths as halves and then fourths and then split. So I have 3/8 here. And if I was to go underneath, the same thing. If I want to use fraction bars, I just drop them down. Now 16ths, I'd have to split it again. This is why I can't go much smaller, because look how tiny these pieces are. But same thing, 1, 2, 3, 4, 5, 6. We stop in the same place. They're both equivalent, just the pieces are different sizes. So we're gonna have a little pizza party with the boys and the girls. So the girls, you are going to get to share 9/24 of a pizza. Boys, you get to share 15/40 of a pizza. I want you guys to take a quick second to think, who gets more pizza? Well, really, we're getting the same amount of pizza, right? Because we know that these are equivalent fractions. So our denominator down here is the total number of slices. So the girls, your pizza will have 24, put a G and a B. And the boys, you'll have 40 slices. The top one will be how many slices do you get? This is the total. So just because the pizza has 24 slices or 40 slices doesn't mean you're getting all of it, right? This is what you get. You get to share. So we're sharing 9 of the 24 slices or 15 of the 40 slices. Now the question is, who gets more slices? Not more pizza, who gets more slices? Right? The boys get more slices. They get 15 slices. But who actually gets the bigger slices? In this case, the girls would actually get the bigger slices because they're in 24ths, not 40ths. If you think about a pizza and you cut it into 24 pieces, I can't actually get there for you because it'd be really small. Versus 40 pieces, we'd have teeny, I'm gonna just split, little tiny pieces of pizza, right? So the girls get bigger pieces, but less of them, while the boys have smaller pieces, but more of them. But in the end, they're the same. We are actually both getting 3/8 of a pizza. So now what I'm going to write for you is I want you to find, how do I simplify this back down to 3/8? I need to divide it by something to get it down to 3/8. We're going to figure out our multiplier for both the boys and the girls. I'll take this one here. We know they're both 3/8, but we have to figure out how to get there. So take a quick second and think, what would our multiplier be? Well, I know that 9 divided by 3 equals 3. And even if you're looking at this and going, I don't know, 24 divided by 8, well, guess what? You know that the numerator and the denominator have to be divided or multiplied by the same number. Same with down here. I know that 15 divided by 5 equals 3, so I know that I have to divide my denominator by 5 also. So the 9/25ths had a multiplier of 3, and the 15/40ths, I guess a divisor of 3, and then the 15/40ths, you're dividing it by 5. But at the end of the day, they're still an equivalent fraction. So we're going to continue on this multiplying and dividing to simplify or unsimplify our fractions. If you need any help today, just shoot me a GM.